why the Q&A widget has a Q in it, but okay. So the topic of today is, what do you do to keep yourself sharp and professional while you are self-isolating and stuck at home and you can't go to work and stuff like that? And I thought, well, one of the things I like to do is practice software kata, the little exercises that get your fingers tuned to doing test-driven development and solving problems. If you've ever done a kata, some of you may have done martial arts at some point in your life, and if you did, and if it was a Japanese martial art, then the word kata probably has meaning to you. If it was a Korean martial art, the word I believe is pumpsa. But whatever the word you use, it's a repeatable form. In the case of a martial art, it's almost a dance that you go through. It's a step-by-step set of motions going around a mock combat scenario. And you practice it precisely. Every motion is tuned and perfect. All the angles of your arms, all the tensity in your muscles, all of the steps, all of your focused eyes, all of that is tuned. And your instructor will come along and correct you as you do this dance. And the dances, these kata can be 5 minutes long. They can be very involved and elaborate. A really interesting thing to watch is two instructors both doing the complementary kata, and then you can see that it is a mock combat. You know, whenever one strikes, the other one blocks, and the two of them will dance around the mat in this really beautiful dance, almost a ballet, although it's a martial arts ballet, of very precisely tuned motions that is always the same every time they do it. Now, that's a kata, and a coding kata is very much like that. It is the solution to a problem using the same strategy over and over again. It's a set of motions that you type into your keyboard in pursuit of solving a problem. Now, obviously, you already know how to solve the problem if you've done it 100 times. And the one I'm going to show you, I've done far more than 100 times. Why then would you practice it like this? Well, why do martial artists do the kata? Why do martial artists practice mock combat? You know, in real combat, you don't go to your opponent and say, excuse me, but which kata would you like to perform? It's not the way that works, right? The reason that they do these kata, the reason a martial artist does kata, is because it allows you, if you know enough kata, it allows you to recognize scenarios in real combat and allows your mind to step back from your body. Your body will know how to react in certain situations, and so your mind can pull back and behave strategically. Now, this happens with coding kata as well, right? If you train your fingers in a coding kata over and over and over again, the same kind of solutions, the same kind of repetitious keystrokes, your body will remember how to respond to certain situations, and your mind can pull back a little bit and behave strategically. Now, this works. I have seen it myself. I know it's kind of hard to believe, but I've seen this happen myself. My fingers will know what refactoring to jump to, what menu item to enact, what thing to do in the moment of coding, and I can sit back, my mind can sit back and kind of plan more strategically. So I'm going to show you one of these kata. I will share my screen and you will see me code it. I hope the internet connectivity is good enough for you to follow along without too much lag and jerkiness. Now, to do that, I need to share my screen. I push this button here and I select that window there, and I believe you've got my screen on yours. Now, what you are looking at now is my IDE. And this is IntelliJ. I like IntelliJ. IntelliJ is a wonderful tool. I'm going to be doing this kata in Java. I know some of you don't do Java. Some of you probably do .NET. Some of you probably do Clojure. Good for you. I would have done this in Clojure, but I figured more people would probably know Java or .NET, and so it's probably more appropriate for that audience. However, I will be doing this in Java. The problem is prime factors. This is one that I've done many times in the past. In fact, I've even set it to music. I'm not going to set it to music today because I'm out of practice, but you might want to go look up, Uncle Bob does prime factors to music and watch that one. Okay, what is prime factors? My son came home from 6th grade or 5th grade, and he had homework to do. And it was mathematics homework, and it was to calculate the prime factors of a set of integers. And he said, "Dad, can you help me with this?" And I said, "Well, certainly, son. I'd be perfectly happy to help you with it. But I'm not going to do it for you. So here's what I'll do. You go to your bedroom, and you work the problems. And when you're done, I will have a little program written for you that will allow you to check your work. It will tell you if you're right or wrong, although it won't give you the answers." He went to his bedroom, and I sat at my kitchen table, and I wrote this little program. Now, I wrote it in Ruby, because I was learning Ruby at the time. I'm going to do it for you in Java, and the solution is roughly the same as the Ruby one that I came up with so long ago. I think the year was probably 2006 or 5. At the time, I had been a test-driven developer for about 5 years. So I was still kind of new at it, still stumbling around. And I sat at my kitchen table and I thought, okay, what I need to do is find the prime factors of an integer. How would I do that? And it occurred to me that what I would do is get an array of prime numbers and then divide the candidate through by those prime numbers. Now, if they divided, then obviously I've got a prime factor. If they didn't divide, then that prime number was not a factor. That left me with a problem. How do I get the array of prime numbers? Well, there's a well-known algorithm for that called the sieve of Eratosthenes, which is a doubly nested loop. You should look it up if you don't know this algorithm. It's very fun to program, the sieve of Eratosthenes. It's really easy to get it wrong. It's hard to get it right, but it's a fun algorithm to write. And so I figured that what I was going to do was write the sieve of Eratosthenes to calculate the prime numbers up to the square root of the candidate. And then I would divide through by all those prime numbers and gather all the ones that divided even. Simple algorithm. And I was about to write that. And then I thought, wait, I'm supposed to be a test-driven developer. I should just start by writing tests and making them pass. And that's what I did. And here's what happened. All right, on your screen, you can see the test setup. This is JUnit running in IntelliJ. Here is the first test. By the way, I'm going to break every rule of test-driven development in this demonstration. I'm going to put a whole bunch of assertions in this one test function. And the function that I'm testing is going to be in the test class. I'm breaking every rule of test-driven development by doing this. Well, not every rule, but lots of rules. But it's going to make it very convenient for you to follow along. So follow along with me. Now notice that the current implementation of factors of returns an empty list. And if I run my tests, you will see that this passes. Yay, it passes the test. I'm a genius. I can write, something that can create an empty list. All right. Well, let's try the next one. The unit test library that I'm using is Hamcrest. You can see it here. Right? Here's the Hamcrest stuff up here. Hamcrest is a lovely little unit testing library that helps with containers and things like that. So, oops, sorry. So, factors of 2. Okay, now this one's not going to be empty. That's going to have contains 2. So the factors of a function will return a list of integers, and that list will contain a 2 and nothing but a 2. This should fail. Oh, my tests failed. Horrors, horrors. Well, actually, I expected them to fail, so it's not that horrible. Okay, now I need to make it pass. Well, I can make it pass by returning a 2 if n is greater than 1. Yes, that sounds like a great idea. So let's take this new array list and turn that into a variable called divisors, factors. We'll call it factors. Good. And then we'll say if if n is greater than 1, factors dot add 2. Oh yes, how clever. Oh my goodness, I'm a programmer. Oh gosh, that worked. Okay. Now, many of you are now sitting there going, this man is insane. He's just putting if statements in. Well, I want you to watch what happens to that if statement. It's really remarkable what happens to this if statement. And it was entirely unexpected by me when I started this. But we've got another test to write, don't we? All right, so we will write factors of 3 contains 3. Yeah, that's the prime factor of 3. Okay, that should fail horribly. Yes, it fails. Oh God, expected 3 but got 2. How can I make this pass? We're going to play a little game of golf. Golf in test-driven development, that's when you've got 2 people, pair programming. One guy writes a test, the other guy has to make it pass. And you play golf by making the test pass in as few keystrokes as possible. Okay, now, what is the smallest number of keystrokes that I can type to make this pass? And I sat at my kitchen table and I did that. And I was surprised that it was that easy to make it pass. Now, at my kitchen table, I sat there for a while just looking at that, thinking that was interesting. I didn't know why it was interesting at the time. Now I do, and I'll tell you in a few minutes. But that was interesting. But there are other tests, so let's get on with this. Factors of 4 contains, well, it's 2 and 2, isn't it? That's what the factors of 4 are. This is going to fail, of course. Oh heavens, it fails horribly. Okay, how do I make this pass? Well, there's no clever little thing I can do here, is there? I mean, this is going to be, it's going to be hard. I'm going to have to put braces around my ifs. I hate putting braces around if statements. It means I'm doing something wrong. Okay, if n is greater than 1, then if n mod 2 equals 0. Yeah, if 2 divides n evenly, right? So, because percent, that's the remainder operator. So if the remainder is 0, then it must divide equally. Okay, I better put braces around this if statement too. And then I'm going to say factors dot add 2, because of course 2 is now a factor. I know that. And now I'm going to reduce n by 2. Oh, look at the divide equals. How many times have you used a divide equals in your life? I'm going to reduce n by 2. And then, so let's work this out. If n is a 4, well, then that's greater than 1. So, well, n is divisible by 2. So then we're going to add it 2. And then we'll reduce n, which is now 4. We'll reduce it down to a 2. And then we'll add the other 2. That should work. So we will run the test. It should pass. Oh, heavens, it failed. It failed. Oh, wait. It failed something else. It failed a different one of the tests. It failed that test. Yes, because 2 is divisible by 2. And then this will reduce n to a 1, and we add a 1 in there. We don't want a 1 in there. See, it said down here it didn't match the 1. We don't want a 1 in there. No, no, no. So if the remaining factor is greater than 1, then we can add it. This is interesting, isn't it? Because this if statement and that if statement are the same, aren't they? Okay, now I'm gonna run the test to see if that makes it pass. Oh, it does. Makes it pass. Lovely, lovely. By the way, you're probably wondering if all this commentary is part of the kata. It's not. When I do the kata by myself, I don't say a word. I just roar through these keystrokes. But here, I'm giving you a little commentary along with it. Now, I want you to look at this because very interesting. This if statement and this if statement are the same. But the one is nested inside the other, and you've got to wonder, why are the if statements nested? And well, wait a minute, do they need to be nested? Let's see if we take this if statement and move it down outside of the first if statement. Does that break anything? No, it doesn't break anything. Now I have 2 sequential if statements that are identical. And you know what that looks like, don't you? That looks like an unwound loop. Well, we've got another test to do. That factors of 5 contains, forgot to comma, contains, 5 is prime, right? So, Bob, can you spell contains? Can you contain? There we go. Now, I think that's going to pass because 5 is prime. Oh, yeah, that passed. Good. Okay, well, that's nice. That was kind of a freebie. Factors of 6. Oh, yeah, contains what? Yeah, 2 and 3. Okay, all right. Well, factors of Bob, factors of this. Okay, see if that passes. I don't know why it would. It passed. It passed. Oh no, that makes perfect sense, doesn't it? Because 6 is even, and it divides through by 2, meaning n is a 3, and then it adds the 3. That one worked too. That's pretty good. Okay. Factors, factors of 7 contains, well, that's prime. So I think that's just going to work right out of the box. Yep, that works. Great. Don't you hate how long it takes the JVM to start? I mean, it takes almost half a second for the JVM to start. If we were doing this in Go, there'd be no startup time at all. Or C, or C++, no startup time. Go, especially. No startup time. Really, really fast. Okay, let's go on. Hey, by the way, that's 3 in a row that just passed out of the box. Even though I was just kind of hacking away and adding random if statements and divides and stuff, we're doing pretty well. Factors of 8. 8. That's right. 8 contains 2 and 2 and 2, because 8 is 2 cubed. Okay, is that going to work? Shouldn't, because nothing will put 2 things in the list. No, it fails horribly because, it got a 4 in the list, and that's because, this one was a 4, and it put the 4 in the list, so that's not going to work. How can we make that pass? Well, we got to divide through by 2 again, don't we? Right? I mean, there's 3 2s in it. We got to keep dividing through by 2. Ooh, let's play golf. Let's play golf. How small a keystroke can we do? Is it really that simple? Yes, it's really that simple. I changed an if to a while. And I sat at my kitchen table. And I stared at that for a while. For a while. Oh, that was just too good. First time I thought of that. Anyway, I stared at that for a while. And I thought something profound happened there. Just by changing an if to a while, I was able to make that pass. Well, okay, there's another one to do. All right, so another test. Factors of 9 contains 3 and 3. Okay, this has to fail because we're only dividing through by 2, right? So that's going to fail. No, heavens, it fails. Okay. Well, how do I make that pass? And, you know, there's a really easy way to make this pass. You see this little loop right here? That little loop is a little engine that factors out 2s. Now, I can write another little engine that factors out 3s. Let's do that. I'm going to copy that, and I'm going to paste it, and then I'm going to change all the 2s to 3s. Yes, Bob, yes. And will that pass? Yes, it passes. But don't celebrate too quickly because that's a horrible solution. That's just the wrong thing to do. I have now broken 2 fundamental rules of test-driven development by doing that. The first rule I broke is to duplicate code. You don't like to duplicate code. Duplicating code is a bad idea. But there's a more important rule that I broke here. It's a rule I haven't told you about yet. And the rule goes like this. Get ready to write this down. Are you ready? Got a pen ready? Okay. As the tests get more specific, the code gets more generic. I'll say that again. As the tests get more specific, the code gets more generic. Look what's happening to these tests up here. Every test adds a new constraint, a new specification. The tests are becoming more and more specific with every new test I write. The test suite is becoming more and more specific. But what's happening to the production code? Well, up to this point, the production code had been getting more general. For example, remember that first game of golf? I turned that 2 into an N. Well, that was making the production code more general because N is more general than 2. And remember when I changed the if to a while? That was making the code more general because while is the general form of if. Think about that one for a minute. While is the more general form of if. But in this last thing I've done, I have made the production code more specific because I added the 3s in there. 3 is specific to the test. If I were to follow this pathway, I could never finish this algorithm because I would have to have a while loop for every prime number. So I'm going to delete this. That was bad. It was wrong. It was evil. But there is a way. I see these 2s. What I need to do is change them to 3s. That's all I need to do for the moment is change them to 3s. But I also have to keep them as 2s. So I believe I have to put this loop into another loop. So let's do this. Let's extract that 2. Let's extract that 2 into a variable called divisor. Divisor, yes, it'll be the divisor. And now we want a loop. Well, if I'm going to have a loop, then I'm going to need to take that initializer and pull it up. That's good. Now, oh, really? Is it really going to be this simple? While? How about, yeah, while? Oh, okay, while. N is greater than 1. Yes, because this loop ends when I have completely factored the integer. And when you completely factor the integer, you will have divided through by every factor, and N will be a 1. Isn't it fascinating that that original if statement, that first if statement, turns out to be the ending predicate, the terminating predicate of this while loop? Oh, I need an incrementer for the while loop, don't I? Okay. Divisor plus plus. Okay. I think I've got it here. Will that pass? Will it pass? Yes, it passes. Heavens, that passes. Oh, wait. Do you see what I see? There's this dangling if statement down here. But this while loop will not terminate until N is a 1. So this if statement is no longer necessary. It really was the terminal condition of an unwound loop. Now that loop is not unwound anymore, I believe. I believe. But that will pass, it does. Okay, I can clean this up a little bit, right? Red, green refactor. Let's do a little refactoring here. This while loop could be a for loop. It does not seem to have an initializer. So I will, don't need the L in there. Okay, and the terminator or the incrementer of the for loop is really just that, isn't it? So I can probably just drag that right in there and get rid of that semicolon. I don't think I've broken anything. No, that worked, okay. And I think I can change this into a for loop. I think I can take that as the initializer of the for loop. Oh yes, look at that, okay. And what's the incrementer of the for loop? Well, it's this guy down here, isn't it? So we're just gonna drag that up into there, reformat it a little, get rid of this dumb semicolon down here. Does that work? Oh heavens, that works. Well, then I don't need these braces anymore. I can get rid of all the braces. You know, I'm on a mission to destroy all braces. I work really hard to get my for loops and my if statement down to one line each. So, is that going to work? Yes, it works. Heavens. Well, what's the next test? Notice, none of the factors are in the main code anymore. The 2's and the 3's are all gone. I wonder if we're general enough. Let's find out. Factors of some big composite number. 2 times 2 times 3 times 3 times 5 times 7 times 11 times 11 times 13. That's some really big number composed of a bunch of prime factors and contains 2, 2, 3, 3, 5, 7, 11, 11, 13. What do you say, guys? Pass or fail? I think we're done. I think we're done with this algorithm. It's 3 lines of code. Where's the sieve of Eratosthenes? Where's that loop that was going to calculate all the prime numbers? Where'd that go? And how does this work? How is it that I'm done and I don't know how it works? Well, I do know how it works. I've studied this many times before, but ask yourself a different question. Where did this algorithm come from? I didn't think it through, at least not up front. I didn't think it through. Now, I did think it through, sort of, as I was writing tests. I mean, everything I wrote because I thought of it, but I kind of got to the end and didn't know I was done. That was really remarkable. As I sat at my kitchen table and my son was coming out of the bedroom with homework all done, and I was staring at the screen going, I don't even know if that's done. And I had to go through the algorithm and convince myself that in fact it does work. And it does. There's a little tuning we could do to it. If you really wanted to get particular, we could tune it by setting the limit of the loop to the square root of n, but don't worry about that. It's really unconsequential. Right? It doesn't matter too much. It matters mostly if you've got a really big prime number and you have to divide through by a whole bunch of non-primes or a bunch of non-factors. Then it might take a while. So if you tried to calculate the factors of a really large prime number, this algorithm would take a while, and you could shorten it by a factor of n squared. By just going up to the square root. But never mind all that. That's not here nor there. What you have just seen is the kata, the prime factors kata. It's one that I do frequently just to kind of warm up. If I'm coming in the morning and I think I'm going to write a little code, and let's just do a kata, and maybe I'll do the prime factors kata, or maybe I'll do the video store kata. There's a whole bunch of them that I do. You can look online for code katas. There's a load of them you can do. And some little kata that takes you 5, 10, 15 minutes to do. Get your fingers all warmed up. Get all the decision-making engines running in your brain properly. So there you go. That's a nice code kata. That is one of the things you can do in this time of the COVID virus to keep your skills sharp and keep your professionalism high. And with that, I think I'm going to turn off my screen share Oh no, that was the wrong thing to do. I pushed the wrong button. Oh heavens, heavens. There, that's the right button. And I believe we're back. So, let's see, what time is it? Oh yes, it's 12:30. That's my time, 12:30 my time. So, from this point on, I think I'll be happy to entertain some questions for those of you who have them. And I see that there are several in the question and answer widget. So we'll start with Jürgen Gmach. I hope I said that right, Jürgen. We are all currently working from home, and it works out great. Isn't it wonderful? You and I live in a time where the technology allows us to work from home. Here we are all quarantined, and we can still do our jobs and get paid. That would not have been possible 30 years ago. It probably wouldn't have been possible 20 years ago, right? Many people probably would not have had access to it 10 years ago. And who invented the technology to allow us all to work from home? We did. We, the programmers, we invented this technology. We invented the transport protocols across the internet. You know, we invented the screen sharing stuff. You think these Zoom guys did that with a bunch of hardware? It's all software. It's all software. All the stuff we're doing is software. It's us. And by the way, we enabled the whole world. You should pat yourself on the back. You're a programmer. Programmers have made the world an awful lot better, especially in times like these. So take a little pride in your profession, because without your profession, everybody would now be out of work. Either that or they'd be exposing themselves to virus. So, Jürgen, sorry, I actually interrupted you. We're all currently working from home, and it works out great. Nevertheless, our boss wants us to come back. Come back. To the workplace and work with masks. How to convince her to let us stay at home? Well, gee. If I were you, I would say, dear boss, I can work fine from home. It is dangerous. It's against the recommendations of the experts. It's probably irresponsible to come together. There's enough technology now that we can teleconference, we can screen share, we can be almost as effective as when we were in the office. Now, by the way, you cannot be as effective. There is value to being together. But in this time of crisis, there is a much greater value in staying apart. And I would make that case to your boss. And by the way, there'd be nothing wrong with getting all of the programmers on the team, or in the company for that matter, to sign a little letter and handing it to your boss by email, saying, hey, you know, probably better if we stay at home right now, because we don't want to bring viruses into our homes and into our families, and maybe spread them to everyone at work. So I think you can make the argument pretty clearly. I hope you can. Let's see. That was Jürgen, and I'm going to answer it live. And if I push that button, oh, it says I answered it. Good. Oh, done. Yes, done. I pushed the done button. Good. Okay, so let's see. Wilson Silva says, I hate putting braces around if statements. It means I'm doing something wrong. Why? Well, so I have this theory about if statements and while loops and things like that. They should all be composed of one line. If you have more than one line in an if statement, or more than one line in a while loop, then that if statement or that while loop is doing more than one thing. And I like my code to do one thing. So I try very hard to extract the contents of if and while loops into separate functions, and I give them nice names. By the way, I have a name for this discipline. It's called extract till you drop. You get the extract function or the extract method refactoring in your IDE, and you use the heck out of it. You extract and extract, extract and extract. And I know everybody says, oh my God, there's been so many functions. Yeah, there will be, but they'll all have nice names, because one of the things you're going to have to do is give these functions nice names. And now I want you to think of what an if statement looks like if the predicate, in parentheses, is a function, and the then part is a function, and the else part is a function, and those functions are well named. Then your if statement will read like well-written prose, because you will say if, and then the name of the function, and then the function will be a little clause, and it'll be well named. If employees should be given a raise, then give employees a raise. Else, don't give employees a raise. Well, you actually wouldn't need that else part, would you? Anyway, that's why I like them to be one-liners if I can. Anonymous attendee says, I am 23 years old already with a working experience as a developer in the field of software engineering. Now I am looking to change my current workplace, and I face the following dilemma, : since I want to have more rapid growth, both personally and technically, in the field of software engineering, should I go to a smaller company to have a big role and therefore more responsibility, but maybe not in the industry? It's scrolling while I'm reading. Maybe not industry best practice workflow, or should I go to a bigger company where I will have a smaller role, but I will experience and see more professional workflow? Do not delude yourself. You will not see more professional workflow in bigger companies. You may see more professional workflow in smaller companies. You will certainly gain more responsibility in smaller companies, and you will work far more effectively in smaller companies. My advice to you would be to stay in the smaller companies as long as you can. My entire career was in small companies, and boy, I would never do anything else. I spent 1.5 years at a bigger company. They eventually fired me, right? Because it was not a good match. I tell that story in the book I wrote, by the way, Clean Coder, The Clean Coder. I tell that story about how I got fired. Yeah, went home to my pregnant wife, pregnant with the one you're looking at here on the screen, and I told her I'd gotten fired. That was not fun. Let's see, Diego Pego. Hello from Brazil. Would you please recommend books, videos for TDD with databases, refactor databases? I find it quite difficult. Well, I agree with you. It is difficult. So books and videos for refactoring and test-driven development refactoring. I'm actually writing one at the moment. So it's not done yet, but I'll give you the title. It's called Clean Craftsmanship, and that will be mostly about test-driven development and refactoring. There are several good books on the topic. Kent Beck wrote a book called Test-Driven Development about 10, 15 years ago. Very good book. I recommend it. Dave Estells wrote a book called Test-Driven Development. And that one was written about 18 years ago. It's also pretty good. Kent Beck's is better. J.B. Rainsberger wrote a book called JUnit Recipes. It's old now, but it is still very relevant. And it answers a lot of questions like database issues and so forth. So that's a very good book. Gerard Metsaros wrote a book called JUnit Patterns. No. XUnit Patterns, because it's for all the testing frameworks. XUnit Patterns. This book is somewhat encyclopedic, right? It's an encyclopedia of techniques and tricks and ideas, all having to do with test-driven development. It's not an easy book to read cover to cover, but it's a great book to open up randomly at a spot and just kind of read a few pages, just like an encyclopedia, or a dictionary. You don't read a dictionary cover to cover, but when you're bored, you go get a dictionary off the shelf and you just open it up randomly and say, gee, I didn't know that. That's kind of way that you would do the XUnit Patterns book. Let's see. Mariano says, I have some problems to do the kata in the real world. Nice there, guy. What do you recommend to do in a crud implementation? CRUD. for those of you who don't know, that's create, read, update, delete. And a crud environment is one in which the software does nothing but create records, read records, update records, and delete records. Every one of those applications I have ever seen still has some business rules in it. They're there, like little validation rules on the create side or on the update side, and on the read side, it's got to display stuff. So you're gonna have to do some formatting. You know, the update stuff is gonna have a lot of validation in the web form that does the updates. Believe me, there's plenty of behavior in there for you to write tests for. Do not delude yourself about writing a CRUD application, because in the end, every application is a CRUD application somewhere in there. Let's see, done, good. Okay, let's go to the bottom here. These people have been waiting a good long time. Ricardo Merlin says, what advantages do you see in using code coverage for TDD? Well, okay, code coverage for TDD is really useful, but you never show the results to a manager, never. Don't ever let managers see the results of code coverage, because they do not know what it means. And they will infer something that they should not infer. They will infer that covered means tested, and it does not. You know that. All the programmers know that, but the manager won't. And the manager may do something monumentally stupid, like saying, the build must fail if we do not achieve 80% coverage. Now that's like the dumbest thing you can do, right? Because then all the programmers have to somehow get the coverage up to 80%. And how do you do that? Well, you write tests that don't assert anything. And that'll get the coverage right up to 80%. It'll get it up to 90%. By the way, when it comes to coverage, what is the coverage goal? What goal should you set for code coverage? Should it be 80%? Yeah. 90%? There is only one meaningful goal for code coverage, and it's 100%. The only meaningful goal for code coverage is 100%. If you set it to 80, what you're saying is that it's okay if 20% of the code doesn't work, right? And it's not okay if 20% of the code doesn't work. So you're not trying to shoot at some goal like 80. You're trying to get it as high as you can get it. Now, can you get to 100%? Probably not. Probably not. It's hard to get there. It's an asymptotic goal. It's a lot like losing weight. You know, you keep trying, and there's another pound to go. Yeah, another pound. Just can't quite get there. It's always the same way. You're always looking at the tests. You're always saying, "Oh, I bet I could get a little more coverage if I just." It never ends. It's a never-ending battle to push to 100%. Let's see, where are we? Oh, that was a good one. Let's see. Do I like aviation? Yes, I'm a pilot. And have you learned something with that you apply to your daily work as a software developer? Yes. Discipline. When you're flying a plane, discipline matters a lot. There are certain rules that you follow in a disciplined way. And you don't question it. So one of the disciplines, for example, is checklists. Right? There's a checklist. The airplane's a fairly complicated device. And you have to make sure that all the switches are set just right, and all the valves are set just right, and everything's set just right. It's really easy to forget. And forgetting would be bad. So we have a checklist. And the checklist sits right by as I'm sitting in my cockpit, it sits right down by my feet, and I can pull it out anytime I want. Flip through it, go, okay, did I remember to do this? Ah, yeah, forgot that. That. You learn very early as a pilot, your instructor will beat it into your head that you pull out the checklist for every time the airplane changes state. That's one of the things that I have learned. And not just checklists, discipline. Discipline is something that you bring to a profession, right? A professional is disciplined. And if you behave in an undisciplined way, then it's very difficult to call yourself a professional. Let's see. My goodness, they don't keep these questions ordered in any sense, do they? Let's see if I can find some. Is it unethical to spend time learning and improving your personal development during slow times at work? No, it is not. If you've got slow times at work, then, making your, improving your professionalism, learning, that's perfectly acceptable. You're a professional. Again, back to this professional. Probably you are salaried. A salaried professional is not paid for the hours that they work. They are paid to get certain tasks accomplished. Whatever you need to do to get those tasks accomplished in the best way possible is within your options, something that you can decide to do. Right? So if you think, today I really need to study a little bit more about test-driven development, there is nothing at all wrong with taking an hour and doing that, especially if work is slow. Now, you've got tasks that need to get done, and you don't want to compromise those. On the other hand, you also don't want to compromise your professionalism, your learning to be a professional. So it's a balance. You have to do both. And by the way, I often recommend that people do that balance by working on your job for, it's usually 40 hours a week, 8 hours a day or 7 hours a day, whatever it is, and then go home and work on your professional skills. And you'd have to spend a couple hours a day or maybe an hour a day or something like that, working on your professional skills. That's always a good idea. There's nothing wrong with doing that at work, but if you're really busy at work, then take an hour or so and do it at home as well. Dakar asks, what is the key aspect of leading teams involved in the field of software engineering where the team members are usually people with strong egos? No. Programmers, strong egos? No. In other words, what is the most efficient way to make the team of developers respect you and maybe sometimes follow your suggestions? Well, wasn't that the million-dollar question? How do you make people respect you? You respect them. Respect is earned, and respect is earned by performing. You do your job well. Consistency, you do your job the same way every time. When you tell people that there are certain rules, you're following those rules, and you respect them. You listen to them, you respect them. You may disagree, you can state your disagreement. If you are in a position of leadership and it is your responsibility to get certain things done and to have them get certain things done, you can tell them what you expect while you're respecting them. But that's how you would do that. Now, is that always effective? No, it's not always effective. What'll happen over time is that most of the people under your charge, if you're the leader, most of the people will conform. They'll say, yeah, okay, this is a good idea. Look at us right now. We're all self-quarantining. We don't want to, right? We may not even agree with it, but we're doing it because there's a certain amount of respect that we have for our leadership. Okay. However, in a team of software developers, there will be some that will not. They just won't. They're going to be rebellious no matter what. And frankly, what's going to happen to them is that there will be a divorce. There's a different set of values. The team has one set and these people have another set, and it's not sustainable. It will not go on. There will be divorce. Now, you may work in a country where that divorce can be enacted by you firing them. I work in such a country. But you may also work in a country where firing someone is not an option. In which case, you must apply the gentle pressure that tells these folks that it would be better for them if they were somewhere else. Okay. Let's see, we've got a few more minutes. Let's see, unit test, integration tests, and E2E tests. What each of them should focus on testing? Okay, so I have definitions for each of these. And by the way, unit tests, the name for unit tests is wrong. And the word unit, no one understands what the word unit is anyway. So I'm going to just use the word unit test, despite the fact that it has no definition. A unit test is a test written by a programmer for that programmer. The programmer writes the unit test as a way to know that they have implemented the behavior that they were supposed to implement, right? The author is the programmer. The audience is the programmer. Other programmers will also be the audience of that test, of those tests, because other programmers will want to know what the behavior of the system is. And there is almost no better way to know what the behavior of the system is than to read the tests. And the tests are all short, brief little snippets. They don't depend on each other. They do not form a system in and of themselves. So they are each understandable, and they each describe one little bit of behavior within the system. So that's very nice. Okay, the next test out, it would be component level tests. Component level tests test the functionality of a component. A component is a chunk of software surrounded by architectural boundaries. Okay, so what's a simple component? Simple component would be the database and all of the code that accesses the database at the lowest levels. That would be a component. What's another component? The GUI. The GUI would be a component. That would be everything on the output side of the system. What's another component? The business rules. Business rules are a component. These are all the processing rules that do what the program is actually supposed to do. A simple application might have just those three components. A more complex application will have more components than that. The GUI itself will be broken down into more components. The database will be broken down into more components. The business rules will have more components. There will be other things that you would want to componentize. The component level tests test each component in isolation. They do that by mocking out all the other components. So you use a mocking library, or you write your own mocks, which is actually better, and you mock out all the other components, and then you test the individual components. The level of coverage you can get that way is about 50%, because half the code in a component is not reachable from the inputs to that component. And why is that? Because it's all error checking code and exception processing code and all the stuff that's impossible that you still have to write code to handle anyway, right? So you can't reach it directly from the inputs, so you get about 50% coverage that way. A next level up are integration tests. Integration tests are where you take two or more components and you tie them together, and then you mock around the outside of all of them, because it's not the whole system, right? And now you are testing the dance of those components. You're not testing business rules anymore, right? You're testing that the components dance. Who writes these tests? Architects write these tests. Technical leads write these tests. The people who understand the system as a whole and the way the whole system is supposed to fit together, they write those tests. And the amount of coverage you're going to have on tests like that is like 10%, because you're not trying to test every business rule. You're trying to test all the interconnections and the plumbing and the dance and the choreography. That's what you're trying to test. Next level up is system test. System test is when you test system from its inputs all the way to its outputs in a production or a production similar environment. Those are often manual. If they're not manual, they can use a GUI tester. And that's inputs to outputs, so everything would be at the GUI. GUI testers are icky, awful, horrible. You can sometimes bypass them by cutting the GUI off and putting a little shim in front and writing automated tests. That's an almost system test. It's more like a big integration test. The amount of coverage that you're going to get off of that is going to be very small. 5%, 4%, 3%, because again, you're not testing business rules, right? You're testing plumbing. That's all you're testing is plumbing. You want to just plumb out every pathway through the system and make sure that works. You don't care about the business rules. You've tested them 2 times already, once with the unit test, once with the component test. there's a whole bunch we could say about this, but I should probably go on to a different question. Malik says, I got 3 minutes left. Malik says, a question on solid, a mnemonic I think we're all familiar with. I have a question specifically for the open-close principle in my book, Principles, Patterns, and Practices. You state that the open-close principle can be achieved by using polymorphism. I find this hard to align with other descriptions I have seen of the open-close principle. Oh, well, okay. The way I achieve the open-close principle most often is to use polymorphism. How? I will have a module, a class usually, might be larger than a class, use an interface, a Java-style interface. And then I will be able to implement that interface one of any number of different ways. The code in the calling module is separated from the code in the called module because the called module is below the polymorphic interface. Because of that, I can change the called module without recompiling, without affecting at all the calling module. Even though the calling module is calling the called module, that polymorphic interface in between inverts the dependency so that the called module depends on the calling module. And that means I can change the called module without affecting the called module. I can change the called module without affecting the calling module. Therefore, the calling module is open to be extended without modifying it. How do you extend it? You change the called module. I hope that clarified that. That gets right into the dependency inversion principle and the whole reason we are object-oriented programmers in the first place. And that makes it 12:59. Is there a simple question here? Uncle Bob, can you elaborate why functional languages are hyped right now? Does it prove that many developers give up on OO? No, heavens no. OO and functional programming are perfectly compatible. You can do OO in functional. You should do OO in functional. And by the way, you should do functional in OO. What is functional programming? It's programming without assignment statements. What is OO? OO is programming with polymorphism. You can do polymorphism in functional programming. That's a discussion for a much longer time. Now it's time to end this lovely little chat that we've been having. Thank you all for your attention. I'm glad you all showed up. I'm glad you are all asking questions. I'm sorry I didn't get to everybody, and I'm going to turn things back over to my lovely daughter, who will advise you of tomorrow's upcoming class.
Hi, everyone. Thank you for joining us today. We hope that you enjoyed it. The questions were great. I have included a link that I just posted for tomorrow's Clean Code, Clean Functions class. It's all day long. There's a couple of spaces left in that class if you'd like to join it. Check it out on that link. And we've recorded this, so we will post it somewhere. I just haven't decided yet where. So look for an email with that information, and we hope you all have a wonderful day. Thanks for joining us.